Thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello everyone, and thank you for tuning in to the 21st Oxygen Concentrator Talk, brought to you by the Oxygen Alliance. My name is Mwavi Lungu. As usual, very pleased to be hosting the call today. So joining me on the call are my colleagues, Teto Sinjani and Timothy Mtonga, along with our technicians from OpenO2 and Sunrise. So I see we have a lot of new faces today, which is a very good thing. So for those of you that may not be aware, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time. So this is where we discuss the different aspects of oxygen concentrator assessment, use, and maintenance. So we always encourage you to send questions to us in advance so that our technicians can have a look at them and then find the right or proper solutions for you. So you can do that by sending the questions to our email, info@oxygenalliance.org. And we can either answer the questions during the call or during the next session of the call. So on the technicians panel today, we have Kowinda Singh, who is joining us from Chandigarh, India. We have Sharon Gozo, Efa Solomoni, Francis Sambani, and Chimwemwe TSC, who are joining us from Lilongwe, Malawi. So we also encourage all of you to keep your microphones muted and your videos turned off, just so we conserve the bandwidth for everyone else. So we also encourage you to drop your email addresses in the chat if you haven't done that already, so that we can add you to our mailing list. So we'll be sending you frequent updates of the next Concentrator Talk and the updates from the Oxygen Alliance. So normally during the call, we also have a topic of interest. So this is where we pick a special one topic and then we just focus on that. So be on the lookout for that also. All right, so now to jump on to our questions for the day. So our first question says, NS brought an oxygen concentrator to our workshop with a description that it was shutting itself down after a few seconds when turned on. When I switched it on, it started running. Then I heard the compressor stop. Then it started again after a few seconds. Then the service alarm came on and the concentrator shut down. What could be the possible cause and solution of this problem? So Chimwemwe, if you would please answer this one.
Thank you, Mwawi. So an oxygen concentrator uses a double head oil-free compressor that takes in ambient air and compresses the air to increase its pressure. So to answer your question, you should be aware that every compressor has its own voltage rating. In places with unstable power grids, sometimes the compressor and the concentrator might be receiving lower voltage than the rated voltage. This can be the cause of the malfunctioning of the compressor. So you should have to test the voltage input from the power source to make sure that you are getting appropriate and unstable voltage. This voltage can be checked at the compressor connector using a voltmeter. If the compressor is receiving enough voltage, then the line capacitor that is connected to the compressor could be the cause of the problem. A defective capacitor can result in jamming or not starting the compressor at all. So replace the capacitor and see if this resolves the problem. Please take note that when replacing the capacitor, it should have the voltage rating and capacitance rating as the previous capacitor, which has been taken out from the compressor. If the capacitor of a higher capacitance than the one the compressor used is used, it results in heating up the compressor. On the other hand, if a capacitor with lower capacitance is used, the compressor will not be able to start. And do not touch or allow any metal object to come into contact with the terminals of the capacitor, since the capacitor is charged and can result in serious problems with shock. Thank you, Mwawi.
Thank you very much, Chimwemwe, for your response. I hope that was clear to everyone else. But then, in case you have some questions or comments, you are free to raise your hand, or you can just come off mute and then ask the question. And then Chimwemwe will respond to any follow-up questions that you might have. All right, seems we do not have any questions there. So we'll be proceeding with our questions. So our next question says, I was working on a DeVille-based 515 oxygen concentrator that was producing low oxygen purity. Before opening it up, I decided to check the pressure at the patient outlet, and it was 58 psi, which is the recommended pressure at the patient outlet in the DeVille-based 515. So even though the pressure was normal, I noticed that the bore in the flow meter was not dropping to the base of the flow meter whilst doing the pressure test. What can be the problem and how can I solve this problem? So I will ask Effa to take this one up.
Thank you, Maui. When doing a pressure test, the air path is completely sealed. That is, the air is not allowed to escape. This is the reason why the bore drops to the bottom of the flow meter. So in your case, if the bore is not dropping down to the bottom, it means there is some sort of leakage that is allowing air to pass through, which is resulting in the floating of the bore even after closing the patient outlet. This leakage can be in between the patient outlet and the flow meter inlet. Another possible source of leakage is the pressure gauge itself. If the pressure gauge is broken in some sort of way, it will allow air to escape out. So to solve your problem, you have to do a leakage test by either using a soapy water to see where there is leakage, or by passing possible leakage spots and observing the position of the bore in the flow meter when you close the patient outlet using your thumb. Some of the possible leakage spots are the bacteria filter, the flow meter itself, the pressure gauge, oxygen sensor for concentrators having the sensor after the flow meter outlet, as well as some of the loose connections. When you solve the leakage problem, you observe that the bore will be able to drop down to the bottom of the patient outlet. Remember to do a pressure test again to make sure that there's the pressure is within the range. If the current pressure you are getting is recommended, there is a high possibility that the actual output pressure is higher. This is the case as the leakage are a bleeding off of some of the pressure. Therefore, after you have fixed your leakage, it is expected the pressure to rise. And since the pressure was initially higher, you will notice that the purity of the oxygen being produced might be higher than it was before fixing the problem. Thank you, Maui.
Thank you very much, Effa, for that explanation. I hope it was clear enough, but if we have some questions or comments on the explanation that she has just given us, we are always welcome to ask those questions. So normally we also have some polls at the end of some of the questions. So after we give out the answers, then we'll raise a poll that is relating to the question. So we have a poll at the end of this question. So Mteto, if you would please launch the poll.
Yeah, sure, Maui. So I'm going to launch the poll now. So the poll says, have you ever fixed a leakage problem in an oxygen concentrator and got higher performance than you initially had? So Maui, if maybe you can just tell people where to access the polls on their mobile phone and computers.
Yeah, sure. So if you are joining us using a mobile phone, if you click on the options menu, another window will open up. So on that window that opens up, there is an activities button. So it's like a triangle, a rectangle, and a circle stacked on top of each other. So if you click on that button, you'll be taken to another window where the pause menu is one of the listed options. If you are joining us using your computer, then you just go to the bottom right of your screen. The icon on the far right is the activities button. So if you click on that, it opens up a window, and the pause menu is one of the options listed.
All right, thanks, Maui. So maybe you should also just remind people to like turn off their videos to save other people's bandwidth and airtime.
Yes, I think that's important. I see, Duncan, you have your video on, so if you turn it on, that would be great.
Yeah, turn it off, ladder. So the votes are in. So I'm gonna end the poll. So I got 11 yeses for people fixing the leakage and having the oxygen concentrator perform better, which is a good thing.
All right, great. Okay, so moving on with our questions now. So our next question says, I was working on an air-safe concentrator that had not been used for a very long time. When I switched on the concentrator, the alarm did not beep. I checked the battery and replaced it with another battery. I switched on the oxygen concentrator again, and the alarm started to beep continuously. I assessed the concentrator but did not find any problem with the oxygen concentrator. What would be wrong with this concentrator? So Sharon, if you would please answer this one.
Thank you, Maui. Okay, so there are several reasons why the alarm can give the continuous beeping sound. So I'll talk about a number of them. So firstly is loss of power. So if your oxygen concentrator is plugged in and turned on, but no power is available, it may begin to beep. So all you have to do is simply turn the oxygen concentrator off, unplug it, and plug it in into a non-working electrical outlet. Secondly, it may be cause of lack of oxygen flow. So this might occur if maybe you've turned on the concentrator, but you haven't opened your flow meter. So you have to do is you have to open the flow meter. If the flow meter is open, but you are still having the beeping sound, it may happen because of damaged or kink tube or a leakage in the system. So to silence this alarm, you simply have to inspect your oxygen tubing for damage or kinks. So replace any damaged tubing and untangle any kink tubing. The other reason is the unit is overheating. So this causes can include being placed in a poorly ventilated room or a clogged filter or even a clogged motor or fan. So if the overheating alarm begins to beep, turn the device off and wait for it to cool down. So turn the device on again. If the problem continues, then the device may require maintenance. So about the alarms on oxygen concentrators, most oxygen units come with a number of safety features installed to avoid damage or malfunctioning of the equipment. So these usually come in the form of audible alarms with or without blinking lights. So while every oxygen machine is different, for other issues on other models, then you need to refer to the concentrator's user manual. Thank you.
Thank you very much, Sharon, for that explanation. I hope that was very clear. But as usual, if you have some questions or comments that you'd like to add on to the explanation that she has just given us, then you are free to do so. Or some experiences that you might have had, then you can also share with us. All right, so I see there are no questions, so we'll be moving on with our questions. Maybe before we move on, just a reminder to those of you just joining us, we always encourage you to share with us your email addresses. So you can do that in the chat. So this will help us to keep sending you updates from the Oxygen Alliance and reminders of the next Concentrator Talk call. So please share your email addresses with us in the chat. All right, so moving on with the questions. Our next question says, while working as an intern at Zao Private Hospital, I was asked to measure the oxygen purity from an oxygen cylinder. While in the process, I noticed that when we use an oxygen analyzer on a concentrator, we get accurate readings. And when we try to use the same on cylinders or an oxygen source with high flow purity, the display on the interface starts fluctuating and no true results are obtained. Any idea which analyzers is recommended? So I will ask Chimwemwe to answer this one.
Thanks again, Maui. So this is a common problem with both handheld ultrasonic oxygen analyzers and electrochemical oxygen analyzers when used on high flow lead oxygen cylinders without satisfying necessary conditions. So handheld ultrasonic oxygen analyzers utilizes differences in upstream and downstream ultrasonic velocities to detect oxygen purity and flow rate. Each ultrasonic oxygen sensor inside the analyzer has a range of flow rate and pressure where it works best, and the range is often indicated on the stick at the back of the analyzer or on the sides or sometimes in its user manual. So high flow rate or out of range flow rates will lead to display of inaccurate oxygen purity as well as flow rate. Electrochemical-based oxygen analyzers also have recommended operating pressure and flow rate at which they work best. So having a pressure regulator set at recommended patient outlet pressure and a flow meter to regulate the flow rate would help to get accurate purity readings from an oxygen cylinder. So thank you, Maui.
Thank you very much, Chimwemwe, for that explanation. I hope that was clear for all of us. Again, if we have some questions, we are free to ask, or if we have some further comments, we're also free to add on to the explanation. So moving on with our questions. Our next question says, I have a concentrator J5 model that is not starting when connected to power. I have tried checking the top plug fuse. It is functioning properly. What might be the problem and how do I resolve it? So I will ask Francis to answer this one.
Thank you, Maui. So firstly, it should be noted that this is a common problem and it was right for the person who sent in this problem to check the top plug fuse. So after checking the fuse and finding out that the fuse was okay, the next thing that the person would be advised to do is to check the continuity of the power cord itself. So that is, you should check the continuity of the live, neutral, and the earth wire if this model has the earth wire, that is. So after that is checked and the wires are okay or the power cable is okay, the next thing that the person needs to check is the fuse. So these other concentrated models of the J5 have a fuse at the back. So the fuse is located just at the at where you connect your kettle cable. So there's a fuse just down there. It's visible in the graphics. So yeah, I hope we can all see it in the graphics. So you should take out that fuse and put your meter on continuity mode and check if the fuse is also okay or not. If this fuse is 40, you should replace it and this will solve your problem. Thank you.
Thank you very much, Francis, for that explanation. I hope that was clear enough. But if we have some questions or comments, we are free to add on to that. So I have to admit that it took me time to realize that you have a fuse under the power, where you connect the power cable. So it might give you a headache if you are not sure of where to find it. So thank you very much, Francis, for that answer. So again, we have another poll at the end of this question. So Mteto, if you would please launch the poll.
All right, Maui, let me do that. So I'm going to launch the second poll. So the second poll says, have you ever come across this J5 model? So give it some time so that people should respond to it. And please remember to turn off your videos so that we save people's bandwidth. So Maui, I see there's a hand.
Yes, go ahead, Kezia. You can unmute your microphone and add any comments that you have.
Or maybe it was raised by mistake. So the votes are split it. So we have more no's actually now. Somebody just voted. So we have more no's as compared to yeses. So it's 5-6. Thank you.
Thank you very much, Mteto. So I see Noel also posted in the comments that you can also try to check the capacitor. Francis, do you want to make some comments on that?
All right, so of course you're right, but then the problem is that if the problem is you have a fully capacitor, you other parts of the J5 would turn on, like the LED or the main control board, that or the fan that would turn on, but then the compressor only will not turn on. So I think the problem was that the whole unit was not turning on, so that's the difference.
All right, thank you very much. Kezai, I see you still have your hand up. So if that was by mistake, may you please lower it? Or if you have a comment, you can just type it in the chat. All right, so this is the part now where we take a slight diversions from our questions and then we move on to a topic of interest. So our topic of interest today will be talking about the filters, the different filters that you'd normally find in an oxygen concentrator. So Sharon will be taking us through that explanation. So over to you, Sharon.
Thank you once again, Maui. So as already stated, today we'll be talking about oxygen concentrator filters. So as you all know, oxygen concentrators have filters that are installed outside of the equipment, on the side, and even inside the concentrator. So each filter serves a different purpose on every position they are placed on. So we'll now talk about why do we need filters on an oxygen concentrator. So an oxygen concentrator takes in ambient air from the surrounding. So ambient air contains millions of particles, some of which will be submicron. So particles of this size can easily enter and clog the working component of the concentrator or even penetrate deeply into the lungs of the patient. So filters are designed to clear these elements from the air before reaching the patient. So we'll talk about the importance of having this on a concentrator. So firstly, the filters protect the oxygen concentrator. So how do they protect the oxygen concentrator? So the concentrator is protected from falling objects that can be sucked and cause a blockage in the compressor, resulting in the concentrator not performing well. It also protects the concentrator from dust that can accumulate in the sieve beds, which affect the performance of zeolite in a concentrator as time goes by. So secondly, they also protect the patient from particulate matter and the risk of infection. So this is where we include the particles that can even cause allergies to the patient. We're also talking about some bacteria that we cannot see with our naked eyes. So the filters are also important in a way that they function as dampeners to reduce the level of noise emitted by the machine. So the concentrator on its own, it produces some noise, but because we have these filters installed, then the noise level is reduced. So we have different types of filters that are connected on a concentrator. And these are, we have the gross particle filter or foam cabinet filter. We have the intake filter, which is also known as the HEPA filter in some concentrators. We have the exhaust muffler. We have the bacteria filter. We also have the compressor filter and the sieve bed filters. So we'll talk about these filters one by one. Next slide, please. So firstly, we'll talk about the gross particle filter or the foam cabinet filter. So this is an external filter that stops any large range from entering the machine case. So the filter has bigger air spaces, giving room for easy airflow into the concentrator. So the gross particle filter is located at the back of the unit, like in AirSafe, Devil Breeze, Canter, Model, Olive, and many other concentrators, as you can see on the graphics. We also have this filter located on the bottom side, like in J5, as shown on the graphics. So the gross particle filter should be cleaned once a week by running under warm water and letting it air dry before placing it back on the concentrator. Next slide, please. So if you have the gross particle filter that is damaged, so all you have to do is to replace it with a new one. So if a new one is not available, don't choose a mattress flexofoam. So you're not supposed to use the mattress fixer foam because it has tiny spaces compared to the gross particle filter. And these tiny spaces can minimize the flow of air into the concentrator. So please don't use the mattress fixer foam. So an example of the mattress fixer foam is what you can see on the graphics. So instead of using this, you can use a gauze bandage. So you need to get a sizable length of gauze bandage and fold it 2 to 3 times. So all you have to do is to make sure that you're folding the gauze to the same size as the filter you're replacing. So you have to use that piece in place of the filter as you wait to purchase a new gauze particle filter. So you need to take the gauze, use plaster to tape it on the back panel to prevent it from falling off. So you also have to make sure that you don't really have to use too much gauze. Like you don't even have to fold it and a load of tens, a number of folds to minimize that can minimize the flow of air into the machine. So all you have to do is just fold it a few times, 2 to 3 times, then you can tape it on the back panel. So this will also give room for easy airflow to the compressor. So if you have replaced the gross particle filter with gauze bandage, you have to remember to change the gauze at least every week, so that you have to be putting on a new gauze, so that you don't really have to have a gauze that is dirty, as that can even affect the performance of the concentrator. Next slide, please. We'll now talk about the intake filter. So the intake filter, also known as intake bacteria filter in other models. So this protects the concentrator and the patient from particulate matter and infections. So this traps most of the dust in the ambient air that is being sucked by the compressor. So it also its efficiency is 99.99%, which is almost the same as the bacteria filter. That's why in other models it's called the intake bacteria filter. So in most concentrators on the intake filter, they use the HEPA filter, which is the high efficiency particulate air filters. So these are the hardest working filters of them all. So it will spend an entire year scrubbing all the microscopic data out of the air that we cannot even see with our eyes. So the longer you run your machine, you may notice that the white plated filter material inside is becoming dirty looking. So this is normal. It means that the filter is doing its job. So stopping the data from entering your machine will absolutely help prolong the operating life of the machine. So this filter, it can never be cleaned, as it would be ruined when you try to clean it, especially with water. So all you have to do is, if it's dirty, you simply have to throw it away and replace it with a new one. So this has to be done at least once a year. So these filters are easily located. So they are found inside the machine and generally can be accessed by removing an access panel found on the inside, found on the sides, or even the back of your oxygen concentrator. So for some of the concentrators that do not use the HEPA filter for the intake filter, so whatever filter that is being used on the intake filter, they have to be cleaned thoroughly. So if the material of your filter cannot support being immersed in water, then you can just blow it using a blower, or you have to replace it with a new one if it's necessary. Or if it's washable, then all you have to do is to just wash it with water, make sure it's clean, and then you let it dry before you install it back into the concentrator. Next slide, please. So now we'll talk about the exhaust muffler. So from the graphics, we can see the exhaust muffler that are used in different models of concentrators. So these act as silencers in concentrators when the beds are roasting. However, it helps in filtering zeolite dust or powder and some data that might be present in the safe bed. So when the muffler has trapped a lot of this data or zeolite powder, they need to be changed, because if you don't change them, then the performance of the concentrator is affected. So they really have to be checked regularly, and if they become dirty, then you need to replace them. If all you can do is blow them, then you have to do that if it's necessary, or if you have new ones, then just make sure that you replace them with new ones. Next slide, please. So on this picture, we can see how the mufflers are connected. So on the left-hand side, that's how a muffler is connected in AirSafe, and the other photo is how it is connected in a DevoBlaze 515. Next slide, please. And now we'll talk about the bacteria filters, which are also known as final bacteria filter. So these are available in different shapes, sizes, and colors, as you can see. So it looks like a spinning top and is found inside the concentrator near the patient outlet. So it is positioned between the flow meter and the one-way valve. So next slide, please. As you can see with the graphics, that's how the bacteria filter is connected, and that's where it's positioned. That's in 515 DevoBlaze. So this filter acts as a sieve. So it stops any micro-sized deity and bacteria from leaving the machine and entering into the patient's nose. So these trap bacteria that are 0.027 microns in diameter, and its filtration efficiency is 99.999%, which is almost the same as the HEPA filters. So for cases where the one-way valve is faulty and water has leached the bacteria filter, you might need to replace it, as the bacteria filter will come in contact with water, which is going to ruin the filter. So all you have to do is replace it with a new one. So when you're pressing a bacteria filter with a new one, you have to take note of the position of the filter, because the filter is leading in on one side and out on the other side. So you need to connect the pipe from the flow meter to the side that is labeled out. And the side that is labeled in, you have to connect it to the pipe that goes to the one-way valve. Next slide, please. And now we'll talk about the sieve bed filters. So the graphics show different types of sieve bed filters. So these are filters that are installed inside the sieve bed. So they are placed on both ends of the beds. So these are of different sizes based on the size of the sieve bed. They're also made of different materials. So these trap any dust particles that try to enter the sieve beds. So in most sieve beds, they are made of soft paper. We have some that are made of cotton. We have some that are made of something like a flexiform. So when you're refilling sieve beds, these filters needs to be changed. So if there's too much dust on these filters, they block the passage of oxygen, thereby affecting the concentrator's performance. So on the graphics on your far right at the top, you can see a dirty filter that has to be changed. So some sieve beds tend to have filters that are flexiform or cotton in nature, as I've already said. So if they can be washed with water, please do so. But I would advise that you really have to be easy on them when washing them, because they are really so soft that they can get damaged easily, or they can even be torn easily. So you have, when washing them, make sure you go easy on them. So when you're done washing them, make sure they are completely dry before putting them back in the bed. So in some cases where water has leached the sieve beds, the filters will come in contact with water, which can end up damaging them. So when you're filling this type of beds, you need to replace them with new ones. It is really necessary. If you can clean them, then you need to clean them up. Then when they're completely dry, you can put them back in the sieve bed. Next slide, please. Now we'll talk about the compressor filter. So from the graphics, you can see the compressor filter. So this is found in 515, 525, and 1025 DevoBlaze model. So a point to take note about filters is you need to keep in mind that it is highly recommended to change all these filters once a year to ensure that the longest life of your oxygen concentrator. So some manufacturers recommend changing the filter about 2 to 3 years. So all this is really stated in the concentrator manual. But however, if the device is being used in a dirty or dusty environment, it may be sensible to replace the filters more often. So what you have to do is to regularly check these filters. So that will determine how dirty the filter is becoming and whether an increased replacement is necessary. So all you have to do is to make sure that you regularly check the filters and see how dirty they are becoming. And if it's possible to change them, please go ahead and change. And if your concentrator doesn't have some of these filters, then you really need to be careful, because when you're using the concentrator on a patient, you really need to have these filters for the well-being of the patient, and even for the better performance of your concentrator, you need to have these filters. So reaching this far, this is the end of the special topic. Thank you.
Thank you very much, Sharon, for that explanation. So I see we have a comment in the chat from Michael. So he says, I noticed that a good number of air sip intensity 10 liters don't have a bacteria filter. However, the internal and external filters are present. Is this a mutual observation? Sharon, do you want to answer this one?
Can you come again on the question?
So he says, I noticed a good number of air sep intensity 10 liters don't have a bacterial filter. However, the internal and external filters are present. Is this a mutual observation?
Okay, from the air sep intensity 10 that I've come across, they have them, and I think they need to have them. So this is one of the filters that most of the concentrators that we have tried to open, they have the bacteria filter. It's something that is really important. Thank you.
All right, Amapreet, I see you have a hand. Go ahead.
Yes, thank you, Maui. I just wanted to comment that there's a standard way that the devices are supplied from the manufacturer, and that would definitely include the bacterial filter. However, sometimes, when they're being used, they end up, sometimes the filters disappear, or, somebody meant to clean it and replace it, but it never ends up getting replaced. We would definitely suggest, as Sharon said, that the devices are used with all of the filters that they should be used with. And if you're not sure of what filters should be included in the device, on the Auction Alliance website, we have the manuals and other information on a lot of the models. So if you need to check, what filters should be included, you can always use that as a resource. And if you find that you need to purchase them, you can also reach out to us at the Alliance, and we can help you get what you need. Thanks, Maui.
Thank you very much, Amapreet. I don't know if we have some further comments from the other technicians as well. Go ahead, Francis.
All right, so Sharon pointed out that the bacterial filter has an in and out, like it has a flow direction, and you're supposed to place it in that way. So I just wanted to further add on that the reason it is so, in some filters you won't find the in and out direction, but most do have the inlet and the outlet. So the main reason is that the filters have some membranes, and the membranes, they're known as microfiltration membranes. So these membranes, in some filters, you have that the membranes are isotropic in that they have the same size, and in others they're asymmetric. So in the asymmetric ones, they arrange them in a way that they differ in the sizes, so as to avoid what they call surface fouling, as in to not trap all organisms just on the surface, or pathogens, I could say in this case. So that's why. So you should always know to place them in the direction as written, in the flow direction. That is. Thank you.
I see Noah, your hand is up.
Yes, please. I have ASAP in 10 liters with me here. There is it does not have the bottle type filter as it is being said, but rather on your left part, when you open, you face it on the left part, there is something like a cottonish something like that. It is plugged on top of the inlet to the compressor. That's the air filter we're talking about. And then it has also the smaller one that is between and the smaller one that is inside. But the air filter is there. The bacteria filter, it is there. but it's not covered, but it looks like a fixer foam, something like that. It just goes to on top of the air compressor. Thank you.
All right. So Maui, are you still there?
Yeah, I had a glitch in my network. I'm back now.
All right.
So, sorry, just to correct Noah, I think what he is referring to is the intake filter, the white thing that is covered on top just directly to the compressor. That should be the intake filter.
Okay, great. Do we have any further comments on this discussion, or we can proceed? All right, no hands. So I guess that means that we can proceed. So thank you very much, Sharon, for the explanation. Now, getting back to our questions. So our next question says, I am a biomedical technician working on an Olive 5 oxygen concentrator. I repaired the compressor and refilled the sieve beds, but no improvement was achieved since the purity was low after the service. I removed the back intake filter and observed that the air sucking wasn't convincing. What could be the problem? So, Effa, can you please answer this one?
Thank you, Maui. When the compressor is running, it becomes hot, making its surrounding air hot also. And the intake pipe gets hot as well due to the increase in temperature of the surrounding area. As time goes, the intake pipe starts deforming since it's plastic. As deformation continues, the intake pipe loses its shape and develops a sharp bend as shown in the graphics. As you can see in the graphics at the far left, the picture shows an intake pipe which is bent, and this bend restricts the volume of air and affects the airflow as well. For this reason, it is not possible to acquire the desired oxygen purity. To solve this problem, remove the damaged pipe and replace it with another one. When replacing the pipe, please be mindful of the angle at which you are installing the pipe to avoid unnecessary bends for easy airflow. You can see in the picture at the light that there is an intake pipe that was correctly installed. Thank you, Maui.
Thank you very much, Effa, for that explanation. I hope that was clear for all of us. In case we have some questions or comments on that, we are also free to come off mute and then add on to the explanation that Effa has just given us. I see a hand from Noel. Is that an old hand?
An old hand, sorry.
Okay, great, thanks. All right, so we have another poll at the end of this question. So Mteto, if you would please launch that one as well.
Sure, why not? So I'm going to launch the third poll. So it's actually asking that, have you ever thought of replacing the intake pipe after a long run of your oxygen concentrator rather? Yeah. So I'm going to leave it for some time so that people should vote. And for those who are joining us for the first time and you haven't sent your email address, please paste it in the chat so that we can add you to our mailing list. All right, so it seems like the votes are not moving so far. So I got 5 no's, so it more is in favor of no's as opposed to yes. Yeah, thank you, Maui.
Thank you very much, Tato. So we'll now be moving on with our questions. So our next question says, can I use an inverter to run an oxygen concentrator? What size of inverter do I need for the oxygen concentrator? So I'll ask Kowinda to answer this one.
Thanks, Mavi. So answer is yes. The oxygen concentrator can run on an inverter. So an power inverter is a device that converts direct current, DC current, usually from battery pack voltage of 12 volt, 24 volt, 48 volt, etc. to 230 or 120 volts of alternating current, AC. An oxygen machine is a sensitive machine that requires reliable power. That is why it is advisable to run it on a pure sine wave inverter that can handle a sensitive load. So a power inverter is the perfect backup option for those who rely on the oxygen machine. Being able to provide oxygen when main power cuts out or isn't available is essential for people with certain medical conditions. Most power inverters are designed to supply a continuous watt, and they are capable of handling surge current whenever inductive loads are first started. So the size inverter you would need for an oxygen machine largely depend on the power consumption of the machine. So for example, for 5-liter oxygen concentrators, the power consumption is between 300 to 400 watts. For all the nearly all concentrators, it is 300 to 400 watts. And for the 10-liter machines, it is from 500 to 600 watts. So for this all this machine, it is generally suggested to use a separate inverter for the oxygen concentrator without any other load. It should be separately installed. So an 1 kilovolt ampere 1 kVA inverter with 180 Ah battery. We can suggest 180 or 200 Ah battery capacity is good for use with the both 5-liter or 10-liter oxygen concentrators. A backup time can be calculated by the battery capacity, that is EHC rating of the battery, into input voltage and divided by load in watts. So say the battery is having a capacity of 180 EHC and the voltage is 12 volt and the power consumption of any 5-liter machine, say it is 300 watts. So it can give a backup of up to 7 hours. So that is a good choice, can be used with the oxygen. Thank you.
Thank you very much, Kowinda, for that explanation. I hope that was very clear for everyone else. But just in case we have some questions or comments that would like to add or ask, we are free to do that. So you can just come off mute and then Kowinda will answer all the follow-up questions that you have. Right, so moving on with our questions. So this is the final question of the day. So our final question says, I have a 5 liter per minute Longfian unit. So this is a J5. When I set it to 2 liters per minute, it reads 95.6. But when I set it to 5 liters per minute, it reads less than 85% to the point that low purity LED light appears. How can I address this? So Francis, if you would please answer this one.
Yeah, okay, thank you, Mari. So clearly, there is a problem, and that is visible after you test it at 5 liters per minute. So what this means now is you have to troubleshoot the problem. So the steps that you need to follow in troubleshooting this type of problem is that firstly, you have to open it up, and since this is a J5, the compressor has a housing outside it, so you need to open the housing of the compressor, because the first thing that we'll have to check is the compressor, if it is performing or underperforming. So to check if a compressor is underperforming or not, an easy test would be for you to have a 1/4-inch hex plug. So you use that, you remove the leaf valve and tie in screw in the 1/4-inch hex plug so that you completely block the outlet of the leaf valve, and then you take the outlet of the concentrator, and then at the outlet you tie in or you place a pressure gauge. So for the what you're trying to read here is the maximum output pressure. And for this model of a compressor, it has a maximum pressure of 102 psi or 7 bars. So you try to read the maximum pressure, and if you see that the maximum pressure, output pressure, is less than 102 psi, that means the compressor is underperforming and that needs to be serviced. But if not, that means the compressor is okay. So if we try to look, can I have the graphics, please? All right, so if we try to look at the graphics, we have images of the piston cup and the compressor sleeve. So on the left, we have the compressor sleeve, and though clearly not visible, but then I think you can see some lining. And that lining is, so you have inside the compressor, you have the piston cup, which is attached to the piston, and then you have the compressor sleeve, and the piston cup continuously collides with the compressor sleeve, and that process, eventually these two things wear out. So this is just an image of how they look like when they're worn out. So if you see that they are worn out as well, you just need to replace them. And I have to point out that for the compressor found in the J5, you find out that the sleeve and the piston cup will match the model ZW370. So if you have GSE ZW370, you can easily replace. You can retrofit, like you can use the models the overall kits for that model and use them in this model as well. So yeah, and after you've fixed this problem, after you've fixed the compressor, what you can do is you don't go straight to refilling the sieve beds, but then you firstly test it to see the performance. Because sometimes it is possible that the zeolite is just okay, and what was failing was the compressor itself. So after you fix this, you're supposed to put everything back together. You remove the quantity checks plug and then plug in. Put in back the relief valve, and then test the period of the concentrator at the maximum flow. And also, it should be noted that every time you're trying to assess a concentrator, you should try to assess it at the maximum rated flow. So if it's a 10-liter oxygen concentrator, you test it at 10 liters. If it's a 5-liter, like this one, you test it at 5 liters per minute. And if you find out that it is still failing, what you need to do now is you can go to the sieve beds and try to refill the sieve beds. So remember that when you're filling the sieve beds, you should always refill the sieve beds when the humidity is less than 50%. So, because zeolite also has an affinity for water, so you might end up damaging the zeolite. So after you've done these two things, I believe this would solve your problem. So just remember to check for leakages, because you'd have refilled the beds, and that gives you like a room for leakages. So just check for leakages as well, and that should solve your problem. Thank you.
Thank you very much, Francis, for that explanation. I hope that was clear for everyone else. But just in case we have some questions or comments, as usual, we are always free to come off mute or raise your hand, and then you can ask those questions. All right, no hands. So it seems we do not have any further questions. So this now brings us to the end of our call today. But before everyone else jumps off, we have an announcement that we have to make. So please bear with us for just a few minutes. So my colleague Amapreet is going to make that announcement. Over to you, Amapreet.
Thank you very much, Maui. So welcome, everyone. We really appreciate you joining us today for the concentrator talk. So I think now everyone knows and understands that our concentrator talk, which is every week, is where you can ask questions, and we will go over troubleshooting and other challenges regarding oxygen concentrators. Once a month, we host a oxygen talk, and the oxygen talk is when we bring in experts that have knowledge about something oxygen related that is not concentrators, specifically concentrator repairs. So next week will be our June oxygen talk, and we will have Martha Gatley from the Clinton Health Access Initiative, and she will be talking about cylinders. So she will discuss cylinder manifolds, safety around cylinders, best practices, and other cylinder related topics. So next week, we will not be answering any questions that are related to concentrator repair. However, I think some of you did add some questions during this conversation in the chat. We will try and email you some answers, and then the following week, back in July, we will go back to our regularly scheduled programming with the concentrator talk. You will now all, thank you so much for sending us your emails. You will get emails from us about these calls, as well as any of the other information and materials that we have at the Auction Alliance. Our website is designed to make it really easy for you to find information about auction concentrators, the maintenance, the repairs, and the questions. Thank you to the rest of you that are putting your emails in now. We do send a fair number of emails. And thank you to all of the new attendees. We hope that you found it helpful. Maui, back to you.
Thank you very much, Amapreet, for that announcement. So I hope we are all going to be here next week for the Oxygen Talk. So a special thanks to the members of the Association of Medical Engineering of Kenya. I saw Simon posted a comment in the chat. We really appreciate you showing up today. So please, we always have this call every Thursday from 2 to 3 p.m. Central African time. So please don't forget to put it on your calendar so that you keep joining these calls. So if you missed all our previous calls, don't worry. We have a YouTube channel where we post recordings of all the calls that we have had previously. So we'll also paste the name of the YouTube channel in the chat. And then when you go to YouTube, you can just search for Oxygen Alliance, and then you'll be able to follow through all the other previous calls that we have had. So reaching this far, I would like to thank you all for joining us for the call today. We hope you enjoyed it. I enjoyed it a lot. One of the best sessions we have had so far. So until next time, wishing you a great week, and we'll see you again in our next call. Goodbye.